Hey everyone, welcome back to another explainer. Today we're taking a macro to micro journey to uncover the invisible systems that literally make life on Earth possible. We're going to break down the fundamentals of our atmosphere and climate and really dig into the incredible science happening right above our heads. Let's get into it.
All right, let's start way up in space. Just look at this magnificent view. What we're looking down at is the protective blanket surrounding our planet. You know, from up here, it looks incredibly peaceful, right? Just a thin, glowing halo hugging the curve of the Earth. But don't let that serene visual fool you. Inside that delicate layer is a chaotic, highly dynamic mixture of gases undergoing intense physical reactions. It's essentially a life-saving physics engine, and it is absolutely vital for the survival of every single living being down here.
So here's our roadmap for today's explainer. First, our planet's invisible blanket. Second, the recipe for air. Third, layers of the sky. Fourth, weather versus climate. And finally, reducing our carbon footprint. We're going from the vastness of space right down to the weather outside your window, and then wrapping up with how we can manage our global impact.
Okay, kicking things off with Section 1, our planet's invisible blanket, the protective shield around Earth.
So, what do you actually see when you look up in the sky? You might spot some floating clouds, blinding sunshine, maybe you feel a gentle breeze on your face. Well, all of these experiences, everything you see and feel up there, are the direct results of this invisible blanket of air surrounding the Earth. It's always there, just working tirelessly in the background.
But wait, why doesn't all that air just float away into the vacuum of space? The answer is gravity. It's a fundamental physical force of attraction between objects that have mass or energy. Earth is massive, so it exerts a strong force of attraction, pulling this whole complex mixture of gases down around the planet. It keeps our atmosphere tethered right to the surface. It's this perfectly calibrated balance, you know? Just enough gravity to hold onto the gases we need to breathe, but not so much that the pressure crushes us.
And that right there is exactly why this blanket matters so much. It isn't just sitting there, it's actively keeping us alive. First off, it acts as a crucial shield, blocking out harmful ultraviolet radiation from the sun that would otherwise scorch the surface. Second, it regulates Earth's temperature by trapping just enough of the sun's energy to keep water liquid and life thriving. And finally, it prevents all that essential heat from escaping right back out into the freezing void of space. Without these three functions, honestly, Earth would be completely unrecognizable.
Before we zoom into the microscopic level, let's pause for a second. Can you imagine what would happen if there were no atmosphere? It's a pretty wild thought. Without it, we'd have absolutely zero protection from the sun's burning rays during the day, and all our planet's heat would just vanish into space the second the sun went down. We quite literally wouldn't exist. Our vibrant world would just be a barren, silent rock. Now that we know what's at stake, let's move to Section 2, the recipe for air, breaking down the invisible gases. When you look at the actual recipe of the air we breathe, you might assume oxygen is the biggest ingredient, right? Since we need it every second. But actually, nitrogen absolutely dominates at 78%. Oxygen comes in second at 21%. And what's really fascinating is that vital gases like argon and carbon dioxide make up just tiny slivers of the pie, 0.93% and 0.04%. But think about how crucial that 0.04% of carbon dioxide is. Without that tiny sliver, plants couldn't perform photosynthesis, the entire food chain would collapse, and our planet wouldn't retain enough heat to sustain us. It goes to show how a fraction of a percent makes literally all the difference in the world. And we definitely can't forget about invisible water vapor. It usually makes up just 0.1 to 0.4% of the atmosphere, but despite being such a minute fraction, water vapor, along with tiny dust particles, is absolutely vital for cloud formation. Without this tiny fraction of a percent, we wouldn't have rain, we wouldn't have snow, and we wouldn't have the freshwater systems that nourish our crops and fill our rivers. All right, zooming back out for Section 3, layers of the sky, moving up through the atmosphere. See, the atmosphere isn't just one big, uniform soup. It's highly organized into distinct layers based on dramatic changes in temperature and density. The layer closest to us is the troposphere, averaging only about 12 kilometers in height. This is our home. The air we breathe is here, most of the water vapor is here, and practically all of our weather. Heavy rain, thick fog, hailstorms, gentle breezes, it all happens right here. Everything that directly impacts our daily outdoor lives happens in this incredibly thin 12-kilometer band. But as we go higher up, past the weather we experience daily, the environment dramatically changes. Way up there in the much thinner air, we find some truly breathtaking phenomena.
These upper reaches are home to spectacular dancing auroras, orbiting satellites, and burning meteors that streak across the sky and completely disintegrate before they ever reach the ground. It's a highly active, stunning frontier.
Coming back down to Earth's surface for Section 4, Weather versus Climate, Understanding the Difference. Let me ask you, how often do you find yourself wondering, is it going to rain today? Or will it be bright and sunny when you're planning a trip outside? We ask these questions constantly. And why is that? Because these conditions change incredibly fast, sometimes minute by minute. I mean, think about how often the forecast shifts in just a single afternoon. So to really distinguish the two, weather is that hour-to-hour and day-to-day condition of the atmosphere. It's why Tuesday can be beautifully sunny and Wednesday can be a humid mess. Climate, on the other hand, is the sum total of those weather conditions averaged out over a massive period of time, usually 30 years or more. A good way to think about it, weather is like your mood today, but climate is your overall personality built over decades.
But here's the kicker. Whether we're talking about a quick daily weather shift or a long-term climate trend, both are driven by the exact same elements. We're talking temperature, precipitation, humidity, wind, and atmospheric pressure. These core variables are constantly shifting, interacting, and ultimately dictating the natural rhythms of human life, agriculture, and our daily survival on Earth. Finally, let's zoom out to the macro picture again for Section 5, reducing our carbon footprint, taking global action. So, climate change. We now know that means a long-term shift in those 30-plus year weather patterns. This leads to extreme conditions and warming that disrupt our entire ecosystem. And importantly, this is driven largely by human activities. Things like burning fossil fuels and cutting down forests actively alter that fragile recipe of air we talked about earlier, trapping way too much heat inside our invisible blanket. But hey, the situation isn't hopeless, not at all. There are very real, actionable steps we can all take to reduce our global carbon footprint. We can save energy in our homes, switch to renewable sources, and plant trees to help reabsorb that excess carbon dioxide. Adopting these eco-friendly living habits is hands down the best way we can work together to protect the balance of our atmosphere. And it all starts with education. Just like students discussing earth signs at the chalkboard, understanding how our atmosphere works is the crucial first step. By learning how these invisible systems operate, we can make smarter decisions for urban planning, disaster preparedness, and build a much more responsible relationship with our environment. So I'll leave you with this final thought for today. Knowing how delicate, balanced, and absolutely vital our atmosphere is, if this invisible blanket is the literal only thing standing between us and the freezing void of space, what step will you take today to reduce your carbon footprint and protect it for tomorrow? Thanks so much for joining me on this explainer. I'll catch you next time.